In the laboratory, there are many surfaces and pieces of equipment that can become contaminated by biological agents or other hazardous materials. Decontamination is required to reduce the risk of infection or harm. Disinfectants, which are chemicals which can kill or neutralize biological agents, are often used for surface decontamination. The choice of disinfectant, its concentration and contact time will all vary depending on the biological agents you are handling. Surface decontamination is usually carried out using liquid disinfectant solutions. Every time you use disinfectants, it's very important that you are confident that you are meeting the following 4 criteria. You are using an appropriate disinfectant. This must be effective against the biological agents you are handling and safe to use on the surfaces you are decontaminating. The disinfectant is within its shelf life, also known as its expiry date. It is being used at the correct concentration. And it's in contact with the contaminated surface for the right amount of time to inactivate any biological agents present. Not all disinfectants are effective against all biological agents, so choosing the right disinfectant is important. For example, vegetative bacteria, that is, not in spore form, fungi, including fungal spores, enveloped viruses, and non-encysted protozoa can be neutralized by a wide range of disinfectant products. Mycobacteria, non-enveloped viruses, and encysted protozoa are more robust and therefore less susceptible to disinfectants. Bacterial spores are the most robust biological agents and are completely resistant to some disinfectant products. You will need to gather information to help you decide which disinfectant to use. This can come from product test data supplied by the manufacturer of the disinfectant, peer-reviewed articles, and in-house testing. A combination of information from these sources would provide the most confidence in assessing the disinfectant's effectiveness. Correct concentration is very important. Too low, and it will not reduce the numbers of biological agents to a safe level. Too high, and the disinfectant could damage the surfaces it contacts. Disinfectants are usually supplied in a concentrated form and need to be diluted before use. You should read the manufacturer's instructions carefully, as different concentrations may be needed for different biological agents. For example, a higher concentration may be specified for use with spore-forming bacteria. The most common active ingredient in disinfectants is sodium hypochlorite, which releases chlorine, usually referred to as available chlorine. Commonly used diluted concentrations include 1,000 parts per million, which equates to 0.1%, used for general surface disinfectant, and 10,000 parts per million, which equates to 1%, used for disinfection of blood spills. Manufacturers will not necessarily use parts per million when giving concentration. They will often use weight, volume, or percentage. For example, the concentration might be described as 5 grams per 100 grams, or 5 milliliters per 100 milliliters, or 5%. These are all the same. If we start with a product concentration of 5%, how do we work out how much we need to produce 1 liter of a solution diluted to 1,000 parts per million? The first thing to do is convert the percentages to parts per million, which we do by multiplying by 10 to the 4, so 5% becomes 50,000 parts per million. We then divide the end-use required concentration in parts per million by the concentrated source in parts per million. So 1,000 divided by 50,000 equals 0.02. We then need to multiply this by 1,000 to give the figure in milliliters. 0.02 times 1,000 equals 20. So we need to add 20 millilitres of the concentrate to 980 millilitres of clean water to give us our 1 litre with a concentration of 1000 parts per million. Remember, most disinfectants will cause harm if they contact the skin, and they may also give off harmful fumes. Personal protective equipment should be worn, for example, a lab coat, gloves and eye protection. Disinfectants should be handled in a well-ventilated area or a biological safety cabinet, especially when handling the concentrated form. It's advisable to put the equipment on a tray to contain any splashes and spills. When making up the diluted disinfectant, you should start by measuring the correct amount of water and then measure the correct amount of concentrated disinfectant and carefully add the concentrated disinfectant to the water. This will ensure that any splashes or spills are already diluted to some degree, making them less hazardous. Not all disinfectants are supplied as a liquid. Some are supplied in tablet or powder form, but the precaution of adding the disinfectant to the water still applies. Diluted disinfectants must be clearly labelled with the name and concentration, and the use-by time and date. Dilution will often shorten the shelf life compared to the concentrated form. The label must also indicate any hazardous properties, for example, if it is an irritant or flammable. The solid disinfectant must have dissolved completely and be thoroughly mixed with the water before it is used. Contact time, sometimes referred to as dwell or exposure time, is the time needed for a disinfectant to be in contact with the biological agents to reduce them to a safe level. This is often overlooked, but it is a very important factor. Contact times may differ depending on the contaminating biological agent. For example, mycobacteria may require more time due to their robust nature. It is important to note that some disinfectant products may evaporate before the full contact time passes. This is more likely in warmer environments. Where this occurs, disinfectant must be reapplied to the surface and left for the remaining time to ensure the full contact time is achieved. The shelf life or expiry date is the length of time the disinfectant product may be stored before the active ingredients begin to break down and the disinfectant will no longer be able to reduce biological agents to a safe level. The shelf life will be noted on the disinfectant container, usually in conjunction with an expiry symbol. Disinfectants must not be used after this date, as they may have become completely ineffective. For disinfectant products that require dilution, the manufacturer's instructions will state for how long the disinfectant will be effective once diluted. This should be used to calculate the use-by date for the diluted product, and this date should be recorded on the container. If more disinfectant is needed after this time, a fresh solution should be prepared. It is important to note that the shelf life of disinfectants may be reduced if they are not stored appropriately. Manufacturers' instructions will describe how their products should be stored, but in general, products should be stored away from direct sunlight in a clean, dry place. Disinfectants may become inactivated by contact with other chemicals or organic materials such as bodily fluids and residues. Solid organic matter can prevent the disinfectant from reaching the target biological agents within and beneath the organic material. In these situations, it may be necessary to clean the area with detergent to remove the bulk of the organic material before surface decontamination with a disinfectant. You may also need to increase the concentration of the disinfectant, increase the contact time, or use an alternative disinfectant product. To maintain a safe working environment, work surfaces should be wiped down frequently. But it is also important to decontaminate surfaces immediately when they are knowingly or potentially contaminated. Keeping work surfaces clean will protect you and those who share your work area from exposure to pathogens. It also helps prevent the spread of contamination outside the laboratory and improves the quality of your work by preventing cross-contamination between samples. The type of work surface and its condition will affect how easy it is to decontaminate and keep clean. Smooth, coated or sealed surfaces are easiest to decontaminate. If these surfaces become damaged due to scratches or cracks, or if they are made of a softer material like wood, they can trap dirt, debris and biological agents. Where wooden surfaces are used, it might be advisable to cover them with plastic. Proprietary laboratory bench coating material can be used, or heavy-duty plastic sheet taped in place will do. Alternatively, a plastic tray could be used, which will also help to contain any spills. If there is organic material or dried residue on the surface, it should be cleaned with warm soapy water to avoid inactivation of the disinfectant from high loads of organic material. Disinfectant can be applied to a surface either from a spray bottle, by pouring it carefully, or by transferring it to a disposable tissue or a cloth for wiping. The disinfectant must then be left for the required contact time. If the disinfectant evaporates before the contact time is up, the timer should be stopped and disinfectant reapplied before restarting the timer. If the disinfectant is a type that leaves any chemical residues that could harm skin or damage the work surface, these should be wiped away using clean, sterile water. Finally, the surface must be wiped dry before use. Hands should be washed after any decontamination procedure. It is important to decontaminate reusable equipment such as glassware before it is washed and reused. Glassware may be fully immersed in disinfectant. Other equipment, such as pipettes, will need to be wiped down. Exterior casings of equipment can be wiped down, but decontaminating interior surfaces may require special procedures, which we'll look at later. If the disinfectant leaves any residue, the equipment will need to be washed or wiped down with clean, sterile water. Even if good microbiological practices and procedures are in place, spills will occur. A spill may appear to be very limited, especially when it's a transparent liquid. Here, switching to UV light activates a dye in the solution, which shows us that it has splashed out over a much wider area. Cleaning up the spill might seem a quick and easy job, but the UV light shows that a lot of contamination has been left on the bench and the gloves. You must always wear appropriate gloves for dealing with a spill, and these must be changed for fresh gloves before resuming work. It's important that people know how to clean up a spill safely and effectively. The initial mopping up must be done slowly and carefully, working inwards from the edges of the spill to avoid dispersing the liquid over a wider area. There will always be some contamination left on the surface, which will need to be cleaned using an appropriate disinfectant. Working like this should ensure that you prevent staff being exposed to the spilled biological agents, transfer of the biological agents outside the laboratory, and cross-contamination of samples. The spill should always be mopped up and removed using absorbent materials such as disposable paper towels or gel preparations. These materials can then be decontaminated by autoclaving, incineration or disinfection before disposal. The spill area should then be decontaminated with an appropriate disinfectant, remembering the basic rules. It should be within its shelf life, of the correct concentration, and left on the surface for the correct contact time without drying out. After disinfection, the surface must be dried before resuming work. This is particularly important on floors to avoid slipping on a wet surface. When clearing up large spills, there's a greater risk of splashing, so you may need additional splash protection, such as disposable plastic shoe covers or rubber boots, a plastic apron to protect the lab coat, and gloves that will protect against the disinfectant. Where possible, leave the area and allow any potential aerosols to settle out before returning to mop up the spill. Work slowly to reduce any splashing and wipe from the outer edges towards the center of the spill so that you don't increase the area of contamination. Once the spill has been mopped up, change gloves and other PPE to avoid cross-contamination. The spill area can then be decontaminated with disinfectant, following the general guidelines. Where a large volume of proteinaceous material has been spilled, such as blood or broth, the disinfectant concentration and the contact time may need to be increased. In addition, the disinfectant should be applied to a wider area than the spill. You may need to move furniture or equipment to make sure you have located all of the spilled material. The surface must be dry before work is resumed. Some laboratories are equipped with spill kits. These contain all the disinfectants and absorbent materials that are needed for dealing with a spill. On rare occasions, spills may occur within equipment. For example, a tube might break inside a centrifuge during a cycle. If this happens, you should follow manufacturer's instructions, but the general procedure would be: stop the machine immediately and leave it for at least 30 minutes to allow any aerosols inside the machine to settle. Put on appropriate PPE. If there is a transparent lid on the centrifuge and you can see that the sealed buckets or rotor are not damaged, then lab coat, gloves and eye protection will be enough. If the buckets or rotor do appear to be damaged, or you can't see inside the lid, then respiratory protection should also be worn in case there is a regeneration of aerosols from the spilled liquid when you open the lid. Carry out surface decontamination of the sealed bucket or rotor in situ before transferring it to the nearest biosafety cabinet. The eye and respiratory protection can now be removed, as the biosafety cabinet will contain any further aerosols or spills. Working in the biosafety cabinet, remove the lid of the bucket or rotor. Pour disinfectant into the bucket or rotor. Spray any unsubmerged parts and leave for the required contact time. Remove any unbroken tubes and discard them. Remove any large pieces of broken tube, then pour the contents of the bucket or rotor through a sieve to capture any small pieces. Using forceps or tweezers, place broken pieces directly into a sharps bin. Mop up any remaining disinfectant using absorbent tissue and place in a suitable container for autoclaving or immerse in disinfectant. Remove any chemical residue with ethanol or water and dry thoroughly. Check the bucket or rotor and the centrifuge for any signs of damage. If it is damaged, ensure it's not used and contact the supplier to arrange repair or replacement. A service visit may be advisable, even where there is no obvious sign of damage. In summary, effective surface decontamination practices must include wearing appropriate PPE, that protects against the biological agents and the disinfectant chemicals. Where necessary, clean surfaces before disinfection. Use disinfectants that are suitable for the surface material, effective against the biological agents, freshly prepared, and within their shelf life. Make sure disinfectants are used at the right concentration and with the right contact time. Disinfectants should be clearly labelled and stored properly. Remove any disinfectant residues with water or alcohol.